Hello, my name is Ben Renwick. I work at Covestro with the Pittsburgh site as the STEM coordinator. Today we're going to be doing an experiment called Chemistry in a Bag. For those of you who aren't familiar with it, it is a great hands-on experiment for students to be able to be introduced to observation skills. Changing different variables within an experiment and noticing different changes within the experiment, such as color changes, temperature changes, formations of a gas, as you'll see later on. So we will be doing this experiment. I'll try to explain the chemistry as best as I can as we move forward. But I'll go over the supplies real quick with you, and also want to explain a couple safety concerns when you do this experiment, because there are certainly some things you want to consider with these chemicals that you're using. So first thing that we're going to use today is called phenol red. This is a solution that I made. I watered it down a little bit, so it's not quite a great concentration as what it was before, just to make materials go a little bit longer. Phenol red is an indicator that will change colors due to different circumstances, and basically tells different pHs of chemicals that are added to it. So it'll change, for example, to like a fuchsia bright pink sort of color if it comes in contact with a base of generally higher than an 8 on the pH scale, and it will also turn to a yellowish sort of color when it comes in contact more on the acidic side, which is something that we'll definitely be able to use as a takeaway for this experiment. So that's the first one. We're also using baking soda, which has the chemical sodium bicarbonate in it, which we will also use for this. So this is our example of our base that we're going to use for this experiment. And then the last chemical that we're going to be using, I don't have it labeled here, but this is calcium chloride, also known as rock salt. This is another part that we'll be able to use for this experiment in addition to. So I do want to caution on a couple things. With the phenol red, it can stain clothing, so make sure if you're a student doing this, or if you're doing with a group of students, that they take caution that it doesn't spill. Otherwise, they will be having this stained on their shirts. So be careful with that. Also, calcium chloride is the other thing you want to be careful with here, because it does generate heat when it comes in contact with a liquid substance. So water, for example, so if students' hands might be damp or something like that, and they end up touching the calcium chloride, they can experience some irritation due to heat on that as well. And also, a gas will be produced in this experiment. It will be formulated inside of this bag. So when students are, after they've created their experiment and they have created carbon dioxide within this bag, it is important that students do not point the bag in any other direction of another student, or that they do not open it themselves at them, because that is a gas that they're bringing in. It's also slightly acidic as well. So just a couple notes on that. So without further ado, we're going to go ahead and do this experiment. There's some different ways to do it. I'm just going to show the way where all the variables are added one after another. You can separate them a little bit out to notice the different changes. I'll kind of explain that a little bit along the way as we do it here. But what I'm first going to do, what's important is you don't want to cross-contaminate anything. So some of these things you can see here, I have a Petri dish with the calcium chloride in it with its own spoon, and I also have the baking soda in another dish with its own spoon. Okay, we've had instances in the past where some students don't know the difference between the calcium chloride and the baking soda, even after explaining it to them, the different textures of what it looks like and everything. So there's been confusion. So sometimes what another thing you can do is you can label them. Labeling is always a good thing to do. Label the spoon in accordance with the right dish. You can mark the colors red for one, and then mark the colors blue for another. That's a way so you don't have confusion whenever you're mixing things as well. So I'm going to take a spoonful of the baking soda for this. Okay, and what's nice about this experiment is every single student can do this experiment. So you get a spoonful of the baking soda inside of here, as you can see. Okay. And then sometimes you might want to measure out the phenol red for this. Typically what I tell students, because every student's going to measure a little bit differently, or if they're adding it using a pipette, it might be a little bit different as well. Typically it calls for 10 milliliters of phenol red to be added to the baking soda. So adjust as needed to. You want to make sure that the baking soda is covered completely or submerged in the phenol red solution that is added in here. So this already had 10 milliliters in it that I measured out. So I'm going to go ahead and pour that in here, okay? And then what you want the students to do, they don't have to close their bags yet, but what you want them to do is mix it around, okay? And it might be difficult to see on the camera, but immediately, as soon as I added that phenol red into here, I could tell that there was a little bit of a color change to it. It's kind of more of a neon looking color, that fuchsia pink that I was talking about. So baking soda, if you didn't know, is a base. And so when it comes in contact with the phenol red, it's going to give you that little bit hint of that fuchsia pink that's in there as well. So that's one takeaway that you can observe from this. The other takeaway, students don't initially realize this, but as they mix it together, if they just hold to that a little bit there, they'll notice that it has a temperature change. And it's not that drastic at first, but if they really feel it out, they'll notice it is colder than the room temperature solution that they were using previously. So two changes you can take away from that. One, the color change as it comes in contact with the base, and then also the temperature change that you'll notice as well. So there's that one. So you can do that one separately. You can do baking soda in water by itself. You don't even have to introduce the phenol red as a color change to it yet, because that's something you can talk about separately. So these are two observations in one. You can separate them out into doing one observation a piece if you have additional bags, or you want to extend this experiment a little bit more to talk about it. So the next part, what's nice about this experiment is that it happens rather instantly. So I have, I'm going to set down this bag here. In this bag, or in this container, is the calcium chloride, okay? Again, just a spoonful. I'm going to try to get a little bit more on the spoon here, okay? But you don't, as soon as this happens, what I advise the students is as soon as you add the calcium chloride, you need to be able to zip shut your bag as quickly as you can, because you'll see what's going to happen here is you're going to get a multitude of changes that you're going to observe here. So we want to make sure that we close as quickly as we can. So let's talk about it, or let's do it first and then we'll talk about it, okay? So you close it, or put the calcium chloride in, you close it, mix it around. As you can see, there's multiple changes that you can notice already. One is that, yes, this is a chemical reaction because it is bubbling, okay? That's an indicator that you can see going on here. The other change that you would be able to notice is the color change, okay? This is in the presence of an acid now. Now, students might not know that from the get-go. This is where the explanation comes into. You can talk about it a little bit here shortly. We'll get to that. But as I stated at the beginning, phenol red, it changes to the color yellow whenever it's in the presence of an acid. So obviously you would have known that at that point. The other thing that students will be able to notice is immediately gives off heat. Now this is another thing that I caution, depending on the ratios of what was added in here, it can get pretty warm in there, you know, upwards of 110, 120 degrees Fahrenheit inside of there. So just grabbing it like this is totally fine, but if students, you know, grab hold of it for a long period of time, it might, again, it's going to be something very, very warm to them. So that's something you want to caution for the students. Sorry, my Ziploc bag kind of came undone there a little bit. So you can see the color change, but let's talk about the other observation, which is that the fact that my bag inflated itself. Okay, there was some air of some sort. I didn't blow any air into it, but from the chemical reaction that was happening here, you can see that there were bubbles being produced. And actually what happened is that this produced a gas, carbon dioxide. Pretty familiar with most students out there, elementary, middle school students. They should know about carbon dioxide as a gas. So that's a byproduct that we're getting from this experiment here. And so it's filling up the bag with carbon dioxide gas. And so once we talked about that, knowing that there's carbon dioxide gas in here, and we know that there's an acid inside of here because it turned yellow, so what acid would that be? Any ideas? And what it is it would be carbonic acid is what was produced inside of here. Okay, so carbon dioxide with an acid, you're producing carbonic acid inside of here. Okay, some bags have inflated the whole way where they look like they're gonna pop. I haven't had any issues with that in the past. Make sure you have a good Ziploc bag, I guess, to hold that to. But again, that's where I cautioned you earlier, where this is gonna inflate with a gas. Certainly don't point it in anyone's direction. Don't open it up at yourselves because you do have a gas in there and a little bit of an acid as well. So you wanna make sure you caution yourselves on that. Disposal for this, I would rinse down the sink with a lot of water. Okay, if you were able to do that. If not, I would open up your bag and then simply toss it in the trash. It's just carbon dioxide, it's just going into the air. But yeah, disposing it down the drain would be the best with water to be able to dilute it. But if you're out in a community setting, you don't have the opportunity to do that, open it up and put it in a bag for it to be disposed of after that. Okay? So that's chemistry in a bag for you. Hope you enjoyed the experiment. And any questions, you can shoot me an email, those of you who are colleagues of mine. Otherwise, this is a great resource for you to be able to use in the classroom. Hope you enjoyed. Bye.